Well, everyone thought they were coming to the F# user group, but I'm going to start by talking about JavaScript because
sacrilege.
That's the kind of person that I am. So this is going to be a slightly abridged version of the talk I gave in Melbourne at the DD Melbourne conference, and it all kind of came about because I've been doing I do a lot of JavaScript. A lot of front-end web is where I spend my time, and been recently doing quite a bit with React and with a library that is fairly synonymous with React, being Redux. And that was the basis for this talk and what I'm going to be covering over tonight. But fundamentally I wanted to talk about Redux and how it's not really just a React thing, and then kind of evolve that beyond it's not really just a JavaScript thing. So for those of you that haven't come across Redux before, I'll do a very quick primer on it. So Redux has three core components. It has an action. This is something that's happened within inside of your system. It could be a user-based interaction. They've clicked a button, they've typed into an input, something like that. It could be a system-generated action. It could be the response of an asynchronous call. It could be a timer has gone off inside of your application to do some kind of an event. An action is then provided to a reducer. A reducer is a function that listens for actions. Depending on the action that it receives, it is able to do something with that. And then that is combined with a store. The store is the central hub of our Redux data flow system, essentially. So, as I said, an action is something that happened. It has some kind of a unique identifier in this. Now, given that this is kind of born out of JavaScript, or like the groundings for what I'm talking about tonight is within inside of JavaScript. We have a property on the object that gets passed around, which is the type of the action that got invoked. There is a chair here, guys, and you feel free to bring up a chair rather than sitting on the countertop over there. It might be slightly more comfortable.
Sitting. Sit down all day.
So an action is basically an event. If you guys have done .NET for as long as I have, you'll be familiar with the event system. You know, it's, particularly inside of the lovely thing like web forms and WinForms. So this is what an action would look like. It's a simple object. This is a function that's an action creator. We invoke this function. We provided a value. We have a type of this action. In this case, the type is echo. And then we have a payload, so some data that was provided to this action creator, or that this action is providing to the reducers as they...
That won't compile, those quotes are wrong.
And moving on from the trolls in the audience. It also won't compile because this is PowerPoint.
That's another problem.
So the reducer, like I said, it listens for actions. It gets given the existing state of the application provided to it. So that comes in as an argument to a reducer, along with the action that was just dispatched from the store. You combine those, or functional programming lingo, you reduce those two objects into a single object, and you produce a new state at the end of the day. So it's basically a pure function. Like, that's the point of a reducer. It shouldn't have side effects beyond itself. You give it state, you give it an action, it produces new state. You don't change existing state. So our non-compiling code that we have here as well, this is a very simple reducer that is capable of handling our echo action, but nothing else. So we're doing a type check on that. What was the type of the action that was dispatched? If it's something that I understand how to handle, I then do something with the payload that's come. In this case, it's an echo action, so it just returns exactly what was given to it. If I don't understand what to do with it, then I'm just going to pass that on to someone else. There might be another reducer that can do something with this, or the action that got dispatched, my system simply can't handle at the moment. So the store is the central hub of what's happening inside of your application. It's the only place where you can change state. It's the only place where mutation happens. As much as from a functional programming perspective, nothing mutates. To be real, something mutates somewhere inside of your application, or otherwise you've got a very static application. So it's responsible for passing actions through the reducers. We also have the concept of middleware, so we can intercept actions as they're being dispatched before they're received by reducers and do something with those. We're also able to, we also then notify people that data has changed within our store, our state has mutated, and we need some kind of notification system that otherwise we can have all this stuff flying around and like data changing within inside of our system, but no one knows that it's happened. So this is how we would create a store. We have a function called create store. We give it the reducer that our application is using. We give it some initial state for the application, so there's no initial state here. We're subscribing to changes, and that's just going to become a basic console log. That console log will then it will ask the store for what the current state is, put that out, and then we're just going to dispatch hello at the end, and that will just get echoed out, and console.log will just put out the word hello. So you notice that the subscribe doesn't actually receive the action that was dispatched. So by the time the subscribers are getting invoked, you no longer know what happened to cause the state change in your application, because you don't want to be allowed to do deterministic things based off of that, because all of a sudden your reducer is no longer a pure function if you're able to mutate around it. So all you can do is ask the store, what's the current state. So just some interesting quirks about the way Redux works is that, as I said, actions, you need some way to be able to identify what that action is. JavaScript being an untyped language, we have a type property that we put on there that we go look at and go, what's the type of this action, make decisions on how we can do something with it. As I said, reducers can't change existing state, they can only return new state. So this actually plays very nice from a functional programming paradigm. Reducers can't return null or undefined or like something that represents nothing, because you can't have nothing as your data representation. Also, from a JavaScript perspective, that can introduce more abnormal quirks that you don't want to have to deal with. Every dispatching action that you do is a synchronous action, so if you needed to do something asynchronously, this is where the concept of middleware would come in. So you just, in JavaScript you might have a promise, it's an AJAX call or something that's happening, you dispatch that, you look at that, you go, it's a promise, so it's not a single object, I'm going to then repack that using multiple actions to represent the stages of that. So the asynchronous operation has started, an asynchronous operation is completed, and they're two separate actions that get fired. So you might be thinking, I've seen this before, it's an event store. And that's essentially what it is. If you spend enough time in the JavaScript community, you'll realize there's one thing the JavaScript community loves to do, and that is rediscover things that people have been doing for a very long time. So congratulations, JavaScript community, you've discovered the concept of an event store. Well done, bravo. But we give it a cooler name so that people think that it's something new and funky, and it's not something that we've done before. Well done. So when I was going through this exercise of wanting to understand how Redux works, I decided that I'd go through the exercise of building Redux, so I decided to create a library called Redux. Do a joke intended there, yes. I won't go into that because I want to move on to the second part of this talk, which is more from the F# side. But I wrote a blog series about dissecting the JavaScript implementation of Redux, how it all works, and basically writing it myself. And going through the motions of what happens at each point of the library and how do you bring this all together. If you're using it without React, this is just some stuff about using without React to use with other popular and less popular JavaScript frameworks. So I wanted to take it a step further. I wanted to prove that you can run an event store in pretty much any programming language, because it's not really a new concept, guys. But also, kind of the nature of the way that Redux works is that it's very well designed around functional programming. Your reducer is pretty much meant to be a pure function. You receive multiple input arguments, and you combine them together to produce a new output. Object reduction style of thing. You can't change existing state, you can only produce new state. Immutability. All these things play very nicely with the concept of functional programming. So, to that end, I decided to implement Redux purely in F#, or at least in what I call writing F#. So, for people that actually understand how to write F#, I'm sorry. I have a much more completed demo that I will get to a little bit later on, but to start with, I'm just going to play around with the F# interactive, see how this works, and then we'll have a look at how it actually comes together to produce. I'm just going to throw that output across the F# interactive, and then we're going to open Redux. There we go. I've imported my module there, and that gives me a function called create store. So create store. Then this just hurts my brain every time I look at it. So it's a generic space function. It has two generic arguments. It has the store state, that could be whatever you want, and then you have the payload that you're providing for the action that's being dispatched. Now, one of the really nice things about implementing Redux in F# is we have a type system. We don't have we don't have this sort of hacky thing that we have to do in JavaScript of faking the type system by saying action.type. We have an actual type system, and turns out what makes this really sweet is union types. So I use union type, or you don't have to, but one way you can use this is the action that you dispatch. The data that's there is a union type, and we'll have a look at that as we start building up this demo. And the last argument there is a sequence of middleware, so a collection of middleware objects that you can, or middleware functions, sorry, that get executed in sequence between an action being dispatched and the reducer receiving the action result. Alright, so I'm going to create myself an action. And this is going to be, we'll just make it a function that has an argument, we'll call it value, and we'll just make it an echo. So it just returns value. Actually, I'll show you how this works with the union types and the value that you can get with there. I'm just going to call this payload, and then that will be, let's have an int of int. Yep, so because I'm not super familiar with the F# interactive, so I might get things wrong here, and if it really starts becoming annoying, I'm just creating a script file, and I'm going to...
You don't put an equal sign somewhere, too?
I do, that's a very good point. Equals, then we go, there we go, pipe, int of int. There we go, okay, cool. We're gonna win a chicken dinner. Alrighty, so now let's create an action which is going to be a func that takes a value and returns a payload .int of value. So we just wrap that around. So this is a very simple action, and we'll just convert our. So we'll be passing in a number to this, and we'll convert it into our union type. Now, if we had multiple different parts to our union, then we could have different actions that construct different things. But this is simple demo. Let's get this done nice and quickly. Then we're going to create a reducer, which will take state and action, and then it will go. Whoops, that, and then we'll do match action with. Okay, match action with. Damn it! How do I enter a new line on that?
You need a white space significant.
Indent it. Yep. I kind of like C# better for some stuff like this. White space significant languages don't really like me and them aren't great friends. Okay, so match that with payload int value, and then we will just go value plus 1. Magic. Okay, cool. So there's our reducer, and then the final thing we'll do is we'll create a store, and we will create store that will take reducer. We'll start with an initial state of 0, and seek empty, because I'm not actually going to use middleware for this very simple demo. The constructor value of reducer is not defined. CER.
Do you need to finish the match?
I shouldn't, because there's nothing else that match can actually do.
Don't think you need the fun.
No, because it's. Do I do it? Okay, so here's where I come back to. Here's where I come back to my demo that I wrote earlier.
You're assigning a function to a lambda.
Redux. There we go, and then we go cat program, and we ignore the fact that I've. Yeah, no, I don't need to. Don't need to do that. It's not any difference. Is it because it's no? It's not different scope because it's new.
Take the fun out and then move the equals to where the arrow is.
Or we do this.
Yeah.
We copy and paste all that code that I've got there. We go restart interactive. Reset. See, this is why I actually did write some code beforehand, and despite what most people see when they come to my demos. All right. Because of gosh, darn it. Whoa. Restart. Then we're going to go to here. I'm just going to everything was a little bit too indented. Okay, we will send that. We will go open Redux. We will then do this. We'll then double that. And oh, I forgot to bring in the type, didn't I? Could do this easier. Okay, and open Redux. Type payload equals union int of int. And we do that, double that, bang. Okay, cool. Finally, we got there in the end. You said that we got the value of 4 printed out. Because we started with 0, we dispatched 4 actions. Each one we just provided the value of 1, so it just kept adding 1 to it. But that's kind of the basic use case of it. So that's how it kind of all comes together and works after you referred back to the code that you wrote earlier. Okay, so how does that all come together? This is the full amount of code that I've required to write Redux, including middleware. It's 59 lines, including a couple of additional things of whitespace, just because I don't quite like the way that F# just kind of collapses everything as much as it can. You know, get rid of as much as whitespace as possible. That annoys my sensibilities. I like to have a break between the type definitions.
I do that too.
Excellent. I'm not the only one that gets frustrated by that. We'll start with the create store method. I'm just going to clap Solution Explorer, so we get slightly more space, and we'll full screen. Okay, so create store, as I said, it's a generic function. We have state and payload as the 2 generic arguments that get passed in. The arguments that get passed into it then are the reducer, so that function that will consume the actions that get dispatched. Any initial state, and then any middleware that could be provided. Now, the middleware I've done as a sequence. You can do this as an option type of an option sequence if you don't want to use seek.empty, and then do like a match if the option type is some or none. I felt that like wrapping that on top of seek.empty, it kind of didn't give me any value. It seemed like overhead on top of overhead, so I used seek.empty. Now, it's one of the things that I miss about C# is overloads. So I really like that I could have an overload that represented this, and you don't have to do all that kind of stuff inside of one function. But then I couldn't, it wouldn't be quite as F# if I tried to do it that way. So the middlewares, and if anyone follows me on Twitter would have seen me post this the other night on Twitter. So this is the signature for middlewares. Oh wait, no, I've run out of screen real estate for that. It is, so middlewares is a sequence of middleware store. So it actually, so each middleware gets a subset of the store for reasons I'll talk about a little bit later. So that store has two generic arguments, the state and the payload, and then it is so it receives that as the first argument. The second argument is a function that returns, that receives the payload and returns the payload. So that's our dispatch function. And then the result of that is that it invokes a function that receives the payload and then returns the payload. So this is just a lot of the same generic argument after itself. And when I first wrote this out, I'm like, how many times do I need to do single arrow apostrophe payload? And I just kept doing it until I got enough and was happy with everything and kept going.
Sometimes you can make it easy yourself by creating a type, which is the function, and then that way you can say, oh, that's the...
Yeah. So I did actually do that in when I was playing around and getting this working. But I kind of wanted to illustrate how crazy it can get, like without having to keep referring back, like up the tree. So I could potentially have removed so I've got some types defined at the very top. You could potentially remove and try and inline them, but then it just gets really funky. Okay, so the first thing I do is determine, did you provide me with a list of middlewares, of a sequence of middlewares? If it's not an empty sequence, so I do have one or more pieces of middleware to execute, I'm actually going to re-invoke create store, but without the middleware. So that means that I need to define create store as a recursive function. This week I learned recursive functions in F#. Because I was trying to work out how to make a function call itself. I'm like, so it's a recursive function. F#, how do I make a recursive function? You add the rec keyword to the declaration. So if we have a non-empty sequence of middlewares, we create the store without middleware. We then grab the dispatch back off the store. So we grab a reference to the original store dispatch function. And what we're doing is we're going to wrap that dispatch method with the middleware. So basically what happens is, so we've got one piece of middleware. When you go store.dispatch, it will actually invoke that piece of middleware. That piece of middleware is then responsible for calling store dispatch. Now, it might be easier if I show you sort of how this works in, let me just go settings and increase the font size here. Is that going to be big enough? No, we'll go up to 24. Okay, so I'll just kind of illustrate how that would look with some TypeScript. So these the first 5 lines represent a series of middleware. So they receive so it's actually a function that returns a function, which is the final thing you invoke. So the first thing is the first function gets a next argument passed to it. So this is the next step of the middleware chain. That might be another piece of middleware, or it might be store.dispatch. It will. So then you wrap that function, and then what you're given back is a function that you then invoke and you give an action to. So we get next, we then get action, and then eventually these are just pass through. So it goes. So call the next step of the chain and provide it with the action. This one is just modifying a value of that action, and so on and so forth. Now in JavaScript, we kind of have to do this as functions that return functions that return functions. But in F# we can take advantage of partial application of functions, which is really nice and means that the really funky looking thing across here is slightly simpler to write and use as middleware consumption, and we'll have a look at that in just a moment. But still, I grab a reference to the original dispatch method. I go through each piece of middleware, and I give them a subset of the store, like this. So they can't. So a middleware can't subscribe to the store. All they can do is dispatch new actions and check what the current store state is. Yep. Question.
So the middlewares don't pass state on between themselves.
No, middlewares don't pass state. They don't necessarily know about state. You have to go out. Actually, this method signature is not 100% correct. Actually, I'll find the actual implementation, or actual usage of a piece of middleware.
What I was thinking was, you have your first middleware, that obviously mutates the state somehow. Does that then get passed into the second middleware?
No. No. An action can't mutate the state because it doesn't. So it can.
So
it
it
can
returns a new state.
No. It can read state, but it can't do anything with the state that it reads. What it could do is it could replace the action that's getting passed through to the next point of the chain with a brand new action that takes some information from state.
So it's only store.dispatch that actually ends up changing the state.
Indirectly, it can end up changing the state.
Through
Yeah.
via the reducer.
Yeah. So the reducer is the only one that will actually be able to finally change state. But
It's only invoked once you get to store.dispatch.
correct. Yeah.
So what middleware stuff does is just basically wrapping a function within another function within another function. And
Yep.
and it just becomes that one function that anyway, yeah.
Yeah.
Yeah. Okay.
So it's one function that eventually changed through. I just realized that my implementation.
Just to make sure I understand that clearly, the function that is really the utility interrupt is the action for your original action producer store.
Yep. Yeah. So the next argument will eventually be store dispatch. One of the pieces of middleware, whichever one is last in the chain, will receive store.dispatch as its next. And if it doesn't invoke that, then store dispatch never gets invoked. So you can use middleware to basically do things like validation. So you look at the incoming action and go, this is a create user, but they haven't provided a username. So we cancel that action, dispatch a new action that is like validation error. So that like the original one just kind of goes off to the garbage collector eventually. I just realized that my implementation of middleware here is not using partial application. I was playing around with a version that that did have partial application, but I don't. Obviously, that code isn't the code that I've actually committed to Git. Whoops. But you can see here. This is how you use middleware. It's the first argument it receives is the subset of the store. The second argument, so that returns a new function that receives the next point to call, which might be store.dispatch, it might be another piece of middleware, and then that's built up kind of at instantiation time, and then this final inner function is invoked every time you dispatch something to the store. We'll see that running in a little bit. So yeah, we go through all our middlewares, we map through them, we give them our subset of the store, so get state, and we also give them a dispatch method. Now you'll notice here that we created the dispatch method as a mutable local variable, and that's because we replaced that with the chain middleware. So we couldn't use store.dispatch here because then we bypass middleware. Instead, we refer up to this local variable, which we're then reassigning down here on line 33. So the final thing we do is we take the original dispatch method, we pass it through to another method that I've got above called compose, and that is the chained up series of middlewares with their pre-bound with the store, and then this will eventually return a store, but we're replacing the dispatch method of the normal store that we get when we call create store with this middleware bound chain through to dispatch. The compose method, this 7 lines of code took me ages to work out and get right. It was such a mind trip. First off, I had to work out whether I needed to use. Porting this from JavaScript, I would use reduce write. Now, there's no reduce write. There's a reduce write method, but reduce write in JavaScript allows you to provide an initial seed argument, initial accumulator. Now, reduce write in F# doesn't. You have to use fold back. Well, it's actually not called reduce write; it's called reduce back. So fold back allows you to pass an accumulator, which is the last args at the end. And then I was like, okay, sweet. Coming from JavaScript, the first argument is the accumulator. The second argument is the current instance. No, that's reversed inside of reduce back. Fold back. It's like, oh man, this just it just was my dad because I just had like constant red squigglies, and I'm like, all I'm seeing is like A apostrophe arrow lambda apostrophe B. I don't know which one's wrong. It was just killing me. But yeah, 7 lines of code, and it would have taken me about 4 hours to write. So the way compose works is we grab if we didn't actually have a chain, then we just end up with a no-op function. We grab the last item off the chain, then we grab everything else. I'm not sure if there's a better way to grab all do that, but that's the way I did it. And then we return a function, and this is essentially this is our new dispatch function that we're returning.
Just to cut you off very quickly.
Yep.
That's sort of like a good section of code where you use pattern matching, but then that's something else to look at.
Excellent. This is in a Git repository. I will take a pull request.
So we can replace all the lambdas with real functions?
Yes, you can replace all the lambdas with little functions and stuff like that. Sure. So then this becomes.
That's good. Yeah.
And that's the idea is that we end up with a single function that, when invoked, calls an array of functions or a sequence of functions one by one in reverse order. In their original order, but using the next one as the first argument that gets passed. So
I get it. Yeah, I've been through that sort of situation where.
And this is where your brain starts really melting, going, "Gah, I get it that you're really smart and you can do a whole lot of really cool type inference, but it doesn't help me when everything is just like generic, arrow generic." Okay, so that's how we deal with middlewares, and that's actually middlewares is kind of the hardest part to shoehorn in, which is why I only wrote it last night. I wrote the rest of this code like 3 months ago, and I'd been talking about writing middlewares for a while, and finally got around to doing it. Okay, so here is the main implementation of create store. So this is what we call it is in the recursive function. So we have initial state, and we have initial state gets passed in, and that gets to the current the state of the application, our current state. We have our subscribers that are listening. Now these are both mutables because somewhere it has to mutate, and I could not for the life of me work out how not to do those two as mutables. We create a dispatch method. We create a subscribe method. The subscribe method actually returns a function that, when invoked, unsubscribes itself. You don't have. So if you want to, you might want to unsubscribe while the application is running. And in JavaScript, it means you don't have to maintain a pointer. You can use anonymous functions essentially. You don't have to maintain function names around anywhere and then call an unsubscribe method. You just invoke the result of calling subscribe. And then we have a get state method, which is really simple. It just returns the current state of the application. And then we return an object that has get state, dispatch, and subscribe. Now, if you're implementing Redux the way that it's done with inside of JavaScript, there is one other function called replace reducer, which allows you to change the reducer of the application at runtime. I did not implement that because that would have required another mutable object, and I didn't want to do that. Also, it's really only used for dev tooling purposes, so it's not really necessarily applicable for what I was trying to achieve here.
We have a static compiler. We don't write bugs.
Exactly. All right, so that's a very long-winded explanation of how you write 59 lines of code. The subscriber thing is kind of cool because basically it creates you a function that just does a whole bunch of mapping and filtering to slice out an item out of a sequence. And I'm sure there was a better way to do this, but I just could not for the life of me work out how you just remove a particular item out of a sequence.
Filter.
Filter? Yeah, but I don't actually. I didn't want to. No, you can't, because you can't do it. So functions don't have equality on them, so you can't check if two functions equal each other. Or at least that's what I recall when I was trying to use filter. Now, someone may correct me in the YouTube comments that we have later on. Okay, so that is the implementation of Redux in JavaScript. So, being a web guy, I was like, sweet, I'm going to build Redux in F#, and what can I do with it? I can make a console application and manage to-dos, because that's what you do with a demo, right? But I'm a web guy. I build websites and web applications.
Shopping cart.
Yeah, I can build a shopping cart. Well, but what it really, if you think about the way Redux is all about, it's about single user state, or it's about application state. Now, inside of a website, this would be this being F#, it would be running on your server. I'm not transpiling this down to with FunScript or Fable or anything like that. This is I wanted to run this on the server, but it's a website. We don't have persistent state on the server unless we're doing shitty things with session or web forms and view state and stuff like that. So, okay,